All right. So, full transparency, we'll probably end class a little bit early today. Um, I'll kind of go through this participation quiz after today's class. Module 9 will have kind of completed everything you need to finish the Module 9 quiz, so that'll pop up there. That, as well as the Module 8 quiz, the participation quizzes from Module 8 and 9 are all due by the end of the day tomorrow. Okay? Because Friday is our second exam, kind of similar to the first one. It'll be available from 11:15 to 3:15. You can get on at any time in that 4-hour time block that works for you. You'll have an hour and 15 minutes to complete it once you start. It'll look like the first exam, majority multiple choice, but some kind of fill in the blank numerical response questions in there as well. I'll talk a little bit more about the specifics of that tomorrow, which will pretty much just be going through practice problems, right? So there's one thing from Module 9 that we will kind of start with, but I'll kind of cover it using the examples that are in the practice problems for the midterm number 2 exam. It's just one final concept that we won't quite get to today, but I think it'll work well kind of reviewing those questions anyways. I think, working through problems for the last topic is really what's the most worthwhile beneficial. So that's kind of where we're going. That participation quiz from yesterday, I kind of got it fixed before I left yesterday. So I apologize. Hopefully we won't have a technical issue. I've checked the one today, so it should be showing up correctly to everybody. Also, a little late for today, but I put up an announcement. My office hours, instead of being in the mornings today and tomorrow, will be between my 2 sections. So 12:30 to 1, or sorry, 12:30 to 2 instead of that additional hour in the morning from 10 to 11. Okay. Any logistic questions for me before we just kind of dive into kind of where we left off in Module 9's material? Okay. Oh, it's not what I wanted to do. I wanted to do this. So we kind of left off thinking about there was this connection between the marginal product of labor and marginal costs, right? And I kind of drew out what that relationship looked like. And we talked about, okay, as I produce more units, right, I can sell them for whatever the price is. That's the additional benefit to the firm. However, because I have to hire more workers to produce more, that's going to increase my cost. Each worker costs money, so my marginal costs are increasing. At some point, the marginal cost will be greater than the additional money I can make selling those units that worker is adding. Okay? So we're going to focus a little bit more on that after this exam. So a little bit of a foreshadowing. We're going to look at how firms make the optimal decision. But for this module, all we're talking about are the firm's costs. Okay. So we've got really 2 types of costs, and we kind of have already referenced them. One is going to be fixed costs. So this was anything that I can't change in the short run. So this in our Chipotle example was like the rent on their building. No matter if I produce 0 burritos or 1,000, I still have to pay that same $1,000 a month to rent the space. Okay. So machinery, things like that, it doesn't matter how much I'm producing, it's going to cost me the same amount to buy that machinery or to pay for that rent. Now, the only thing that we'll think about up to this point that can change, in the short run, we're going to be thinking about we can make labor decisions, right? We can hire and fire workers. Now, there are other examples of things that are variable costs that can change in the short run. So, I could switch my supplier. If I'm making burritos, I switch my, chicken or corn supplier. I can reduce the cost of my materials maybe. So there might be things that other than labor that are variable costs, but for the sake of what we're going to do, we'll just think about them as labor costs for this module. Okay. So fixed costs, things that I can't change in the short run, right? And don't depend on how much I'm producing. Variable costs, those will be increasing. If I want to produce more units, I've got to hire more workers. So that's something I can change in the short run. And there, my variable cost will be a function essentially of how much I want to produce. And then total cost will just be the sum of those 2 things. That's pretty easy, right? So total costs are just my fixed plus my variable. Okay. So we think about what these cost curves look like. The easiest one is going to be my fixed costs, right? Because it doesn't matter if I'm producing nothing or 6 units or 4, my fixed cost, right? The cost to rent my space in our other example is always the same, right? It doesn't depend on my production, okay? Now so that's kind of easy. That's just a horizontal line. My variable costs, right? We're going to have that as I want to produce more, they're going to be increasing. I'm going to have to start hiring additional workers, right? Now, what'll end up being true is to get that first unit, and this is kind of weird because I have quantity jumps of 1, but as I want to produce more units, I've got to hire more workers. I have to hire less and less effective workers. Right? So every additional unit, right, is going to raise my costs, but maybe before I only need to hire one more worker to get one quantity of 1, maybe I've got to hire additionally 2 more workers to get that second unit. So we had this idea of our variable costs, right, are going to be increasing. And when we start to think about, well, what's the change in those variable costs? We said, potentially, initially, I have some gains from specialization occurring, whereas I hire more workers, they can specialize, and so they're becoming more effective. My kind of costs per unit we can think of for now are going down, right? So we had this initial decrease in our marginal cost, but eventually those diminishing returns to labor took over. We're hiring less and less effective workers, which increased my cost of producing one additional unit. So we have this kind of upward sloping marginal cost. That's going to represent the slope of this variable cost curve. It's becoming steeper and steeper. Now, if my total costs are simply my fixed plus my variable costs, right? So notice 100 plus 0, 100 plus 70, 100 plus 120. The difference between my total and my variable costs will always be whatever my fixed costs are, okay? So the difference between my total and my variable cost, this isn't quite drawn to scale because this should always be the same amount, right? It should always be $100, okay? So we typically aren't as focused on these total cost curves as we are going to be with the average and the marginal costs, okay? So we've kind of already discussed how we calculate marginal costs. So if I have my total costs there, I can see that they're increasing, okay? How much are they increasing by? Well, marginal anything is the change in that thing divided by the change in whatever's causing my cost to change, right? So I'm producing more units, that's causing my total cost to change. So here, how did I find the marginal cost of 70? Well, it's just the change in my total cost going from 0 to 1 unit, so 70, divided by that change in quantity. Here we've got an easy example where the changes in quantity are 1. So 70, 50, 40, etc. So initially, right, we said we'll see that marginal cost could be decreasing because of gains from specialization. But eventually, after we exhaust those gains from specialization, we know that because we're hiring less and less efficient workers, we're going to see the marginal cost, for that product start to rise, okay? So that diminishing marginal product kind of principle takes over, and we end up with something that looks like this, okay? So in this initial range, right, from like up to a quantity of what, 2.5, our marginal costs were going down, so we must have had gains from specialization. Once our marginal costs start increasing, that'll be where these diminishing returns take over, right? So kind of notice past that quantity of 3, every quantity past that, the marginal costs are going up. And in some examples, not this module, but after the second exam, sometimes we'll use a simplifying assumption, which is we'll use constant marginal costs. This is more realistic in certain scenarios. We'll talk more about that in the 4 modules that come after the second exam. Right? But for now, we're thinking about we kind of have this Nike swoosh symbol, right? Initially, marginal costs might start to decrease. Once gains from specialization are gone, diminishing returns take over, and my marginal costs are increasing. Okay. So if instead of thinking about the marginal cost, we want to start thinking about the averages. Okay. So all an average is I take the total, right? If I want to find my average grade, I add up all of my, let's just say I have my average quiz grade, add up all my quiz scores, divide by the number of quizzes I had. Same kind of idea. Average fixed cost, I would add up all my fixed costs. Well, my fixed cost is always the same value. Divide by the quantity I'm producing. So if I have the same value, right, and my average fixed cost is just that fixed cost divided by quantity, as I produce a higher quantity, so if my average fixed costs are my total fixed costs over quantity, as quantity goes up, what's going to be happening to my average? Well, I'm taking that same fixed cost and I'm spreading it out over more units. dividing by a larger number, that entire fraction would go down. So if I'm thinking about my average fixed costs, initially they'll start out relatively high, but as I spread them out over more units, that average fixed cost will be decreasing, right? Getting closer and closer to zero. Imagine even if I have a fixed cost of a couple $1,000s, if I'm producing tens of thousands of units, the average fixed cost would be really close to zero. Okay. So there, if we went through these numerical values, all I'm doing is taking the fixed cost. You can't really divide by zero, so at a quantity of zero, we don't really have an average. But at that first unit, 100 over 1. However, when I produce 2 units, it's the same fixed cost of 100 spread out over 2 units. Now it's only the average cost per unit is 50. And then if I spread it out over 3 units, the average per unit fixed cost is only 33.3, etc. So we kind of notice here, our average fixed costs are falling as we produce more and more, or we get this average fixed cost curve that's getting closer and closer to zero. Okay. Now, if I think about my average variable costs, that's just going to be take your total variable costs and divide it by the quantity you're producing. So at zero, we can't really do anything. At a quantity of 1, my total variable costs were 70. 70 over 1 is 70. At a quantity of 2, my total variable costs were 120. Divided by that quantity of 2, I would get average variable cost of 60. So what do I notice is initially happening to my average variable costs? Well, because we have this initial portion from gains from specialization, initially when I want to produce more, my workers are becoming more effective, my additional costs are lower and lower, so our variable costs, when we look at the average, are actually going to be going down. Now, there will become a point where those gains from specialization are gone, diminishing returns starts to take over, and I start to see past this quantity of 4, what's happening to my average variable costs. Well, now they start to increase, right? Now the fact that to produce more units, I've got to hire less and less effective workers, that's kind of taken over, okay? So initially, we'll have this decrease in our average variable costs, and then at a certain point, it'll start to increase again. So we kind of have this U shape to our average variable costs, okay? Average total costs, right, are just going to be my total costs divided by quantity, same sort of ideas with variable costs. Now, we'll kind of notice initially, they are decreasing as well. And then at a certain point, past this quantity of 5, my average total costs start to increase. So we're going to end up with, put these on the same graph here. If I think about, we had my average variable costs, right? What's going to be true if I were to draw my average total cost curve in here? Well, ends up being true is if my total cost is just my variable cost plus my fixed cost, if I divide everything by the same value, that equation should still hold. What do I now have? The average total is the same as my average variable plus my average fixed. So when I'm drawing in my average total cost, it will always be what? Above the average variable, right? Because this is going to be something above zero in the short run. I'm going to have some fixed costs. So initially, my average total cost might start out here above the average variable cost. But as I produce more and more, what's happening to this value? It's going down, getting closer to zero. So as I produce higher quantities, what's happening to the gap in between average total and average variable cost? It's getting smaller and smaller, right? Now, they'll never be exactly equal to each other as long as we have some fixed costs, right? Even when these get close to zero, there's still going to be some gap. But you can kind of think about that average total cost will always be above average variable, and the gap in between it is our average fixed. So if our average fixed costs are getting smaller and smaller, the gap in between those two is getting smaller and smaller as well. Okay? All right. So the lights were playing tricks on me again here. So we'll go back to the slides. So we've got our average total cost, all right? I kind of already mentioned this, but we can rewrite this, just divide everything, or we can rewrite total cost is equal to fixed plus variable. It ends up being that our average total is also just the sum of average fixed and average variable. So if we go back and grab those numbers, sure enough, I calculate my average fixed and my average variable costs, those should add up to my average total. And then I kind of already drew this for you as well. All right. But we've got our average total cost. Our average variable cost will be below that. The gap in between the two is closing because the gap in between the two was this average fixed cost. Okay. So it's a different way of looking at what I kind of drew out for us. Now, our marginal cost, we can also add in here. And I'm going to jump the gun a little bit at this point, but it's going to relate to something we talked about last class. So where will my marginal cost curve be at? And I'm going to clean the graph up a little bit. We're not going to worry about average fixed cost for right now. I'm just solely going to focus on my average variable cost, right? So we have this average variable cost that kind of has this U shape to it. And here we're kind of thinking about like dollar amounts. It's on our y-axis. My marginal cost initially will be decreasing because of gains from specialization. Now, any quantity below this point, my marginal costs are below the average variable costs. So if I think about, well, my variable costs are simply coming from the fact that I'm hiring more workers to increase my production of the good. So when the additional cost that a worker is adding is below the old average, what should be true about my new average? It was the same idea as our quiz scores, right? If my average quiz score was 15, right? So that was my old average, and kind of my, well, let's say module 8 quiz. Let's say I got an 18, or not, no, we're doing this one first. I got a 10, right? Well, the marginal quiz grade is below the old average, so my new average is going to be what? Something below 15, right? It's going to pull my average quiz score down. Same idea. When the marginal cost is below the previous average, my new average should be lower. Okay. And then over in this range, here my marginal cost for all these quantities is above the old average. If that's the case, I'm adding a cost that's above what my previous kind of per unit costs were. That's going to pull up the average. So there, my new average should be going up when the marginal cost is above the old average. Okay. So what will end up being true is that marginal cost hits the average at its minimum point, right? So the point where they intersect, that's the point, because we have these increasing marginal costs eventually, right, after gains from specialization are gone. We know that whenever marginal cost is below the average, our new average is getting lower. As soon as they're equal to each other, that will be where my average is at its lowest. Any quantity past that, my marginal costs are still increasing. They're now above the average variable. My average variable costs here should now be increasing. Okay. But because it's an average, they won't like be exactly the same. When I'm calculating an average, I'm using the new costs as well as all these old lower costs as well. Okay. So the same kind of relationship that we had between the marginal product and the average product of labor, same thing for the marginal cost and the average variable cost. Okay. Any questions on that idea before we return to the slides here? Okay. All right. So what'll also end up being true is not only does marginal cost hit the average variable at its minimum point, it'll also end up, the same principle would apply, it hits the average total cost at its minimum point as well. It's just that quantity where it hits average total cost will always be at a higher quantity, right? Because those average total costs include not just my variable, but also my fixed costs, right? So those will always be a little bit higher, which means they'll always be above the marginal cost for some quantities where that marginal cost is not below the average variable cost. Okay. So we'll look at some actual numbers. Here's kind of our cost equations. I'll get up a Word document that has these in here as we're thinking about getting ready for exam number 2. But really, it's just my total costs are my variable plus my fixed. That also implies that my average total is the same as my average variable plus my average fixed. How do we find averages? Whatever we're looking for the average of, we just take that total, so total cost, total fixed cost, total variable cost, and divide it by the quantity we're producing. And then marginal cost, we said it's the change in our total cost divided by the change in quantity. And I'll kind of relate this in a second to our variable and total costs as well. Okay. So let's say I had a table that looks something like this, right? So usually if we were in in-person class, I'd have you kind of work with the people around you, try to fill out as much of this table as possible. I'm going to work through this and show you how we could fill out this entire table, even though we only were given, what, 5 pieces of information here. So I'm just going to write this out for us. Have this pulled up so I can see it maybe. There we go. So we've got, and here, this first example will be a little bit easier because the quantity jumps are 1. We'll eventually look at something where we don't have quantity jumps of 1, but we've got to walk kind of before we can run here. So total cost, average variable, average fixed, average total, and then our marginal cost. So kind of give myself some grid lines so we can kind of keep things separated here. Okay, so we knew this value, we knew this value, we knew this value, and this value. So the first place I would always kind of start with in these examples is thinking about trying to find my fixed costs, right? So when I'm filling out this fixed cost column, it should be the same value no matter what level of production I have. So another kind of hint is usually like start where the quantity is equal to 0 and thinking about fixed costs. So if I look at when I'm producing nothing, what would my total variable costs be? Well, if I'm producing nothing, how many workers do I hire? 0. So I have no variable costs, which means all of my total costs must be what? Fixed costs. Okay. Once I know the fixed cost in one of these places, I know the fixed cost at every single quantity. Okay. Now, once I know my total fixed cost, how could I fill out my average fixed cost column? It's simply taking that total. Now, we can't find averages when we produce nothing, but at that first quantity, if my total fixed cost is 720, 720 divided by 1 would be 720. Now, if I have those same fixed costs, but I'm producing 2 units, it's getting spread out over 2 units. 720 divided by 2 would be an average of 360 per unit. And then 720 divided by 3 would be what? Doing math in my head correct, 240. And then 720 divided by 4 should be what? 180. I'm doing math in my head there, correct? Okay. All right, so we've got our fixed costs. What are the next things we can maybe start to fill out? Okay. Well, now the second thing I'm going to do is kind of use this idea that the total cost is equal to my total variable plus my total fixed. Also that my average total is equal to the average variable plus the average fixed. Okay. So if I'm looking here, how can I find my total cost at a quantity of 1? Well, if I know my total variable, I know my total fixed, just adding those two together. Now, a little bit more difficult maybe if I only know my total cost. So here, I've got my total cost is 740. I know my total, I don't know my total variable cost, but I know my total fixed cost is 720. Well, there's just a little bit of algebra. Subtract 720 from both sides, and I get that my total variable cost at a quantity of 2 would be 20. Okay. Now, these are a little bit more tricky because I don't know my total cost. I don't know my total variable cost. But what can I do? Well, I can start to use my averages to back out what those totals are. Okay. So if I think about here, if I wanted to find my total variable cost, right? Well, I know that my average variable costs are equal to my total variable costs over quantity. So at a quantity of 3, my average variable cost is 15. it's just a little bit of algebra to see my total variable cost would be what? 15 times 3 or 45. Okay. Now, what should end up being true is if I were to add my total variable and total fixed, that should be my total cost. Okay. One way I could check to make sure my math is correct is also, well, what should the average variable plus the average fixed cost be? That should just be my average total. Right? So one way I could check this, see if I can get this here, is my average total cost should be equal to the total cost over quantity. So if I'm looking at a quantity of 3, and I've got this average total cost of 255, if I do a little, there we go, a little bit of algebra here, my total cost is equal to 3 times 255. Sure enough, that would give me the same value of 765. Okay. All right. So let's see if I can get this all in the same. There we go. So what else don't I know? Well, once again, I don't know my averages here, but how do I find an average? I simply take the total divided by quantity. So here my average total cost is just 727, 727 divided by 1, 740 divided by 2. So that's going to be what? 370 if I'm doing math in my head correct. And then how do I find my average variable cost? Well, I would just take my total variable cost divided by quantity. So this would be 7, 20 over 2 is 10. Well, I still need to do a little bit of work here. Oh yeah, if I know my average fixed is 180, my average total is 202, what must my average variable be? The difference between those, right? So I could then use these values to compute my totals, right? So once again, if my average variable cost is my total variable cost over quantity, then here at a quantity of 4, if my average variable cost is 22, a little bit of algebra, I get my total variable cost is 4 times 22, or 88. Right? And then I could do it a couple different ways. I could use average total to back out what this is, or I could simply just add my total variable, my total fixed cost to get that total cost. Okay. So we can use those average cost equations to kind of fill out a large majority of this table. The more difficult one is going to be this marginal cost column. Okay. So any questions before we kind of move on to this idea of the marginal cost? Okay. Now, this example will be a little bit easier. I'll go through a little bit more difficult one in a second here. And I'll point out some things from these numbers that we've talked about. So how do I find my marginal cost? It's the change in my total cost divided by a change in quantity. So all I'm going to do is look at that change in my total cost divided by the change in quantity. Well, the first one's easy in that I'm going from 727 to 720, or sorry, from 720 to 727, from 0 to 1 units. So I get that this is what? A marginal cost of 7. Now here I'm going from a change in my total cost of 13, but the change in quantity is still 1. So 13 was the difference here. Then it's 25. Here's what? 35 plus 8, so 43. Notice what's happening to my marginal costs as I'm producing more. They're increasing. So this is actually an example where marginal costs were never going down. So I must have no gains from specialization. I only had diminishing returns to labor here. Okay. Any questions on that idea before we keep moving? Okay. Now, I wanted to point something else out here, which is I can use the change in my total costs. In the short run, my fixed costs are never changing. So any changes in the total are coming from changes in the variable costs. So I actually could also find this using the change in my total variable cost. Notice there, what's my total variable cost changing by? 7, 13, 25, 43. I get the exact same values. So I can use the change in total cost or in total variable cost when computing marginal cost because the changes that occur in total cost are only coming from changes in my variable costs. Okay. All right. Any questions there before we go back to the slide? So we just filled this out, right? I kind of have already alluded to this, so I'll go through this a little bit quick, but why do we have this U shape kind of to our average cost curves? It really came from the fact that, initially my average fixed cost, which is part of my average total, is falling pretty quickly. Now, eventually, because I've got, oops, excuse me. So initially when I'm producing more, I'm spreading that fixed cost out over more units. I'm pretty dramatically lowering my average total costs. But eventually, I'll get to this portion where because my workers are less and less efficient, to produce more units, it's going to require me a lot of workers or really increase my costs. And so now I start to see that average total cost curve is going to start going back up. Okay. This minimum point we will call the efficient scale, right? Well, what did we say is true at that minimum point? That's where my marginal cost curve, my animation's a little bit off here. I didn't quite hit it, but it's where my marginal cost hits the average total cost. That minimum point is going to be what we call the efficient scale of production. And then when said any quantity below that, when my marginal cost is below, so my marginal cost here is below the average, my new average was getting smaller. And then at any quantity above that efficient scale, the marginal costs, right? My average total cost is below the marginal costs, or marginal costs are above my average total. So what's happening to my new average total? It's going up, right? So kind of already talked about this. This point where they intersect will be the minimum point of the average total cost curve. And they will always look like this, right? So you can always draw your U-shaped average total cost and then a marginal cost curve that hits it at its minimum point. And then all those things will be true, okay? So since I already kind of drew this out for us, I've got a numerical example where we can kind of do the same thing. So I added something into the slides that I don't think were in the ones you downloaded. So initially, this was giving you an average total cost at 0. Technically, we can't find averages at 0. So let's just assume, the reason why I had that, let's assume we had fixed costs of 10. Okay. So here I've got jumps in quantity not of 1, but different amounts. So if I wanted to produce the first 20 units, maybe we'll assume that each worker costs me $5. Now, maybe this is like an old example, minimum wage, $5 an hour. So I've got my fixed cost of 10. I have to hire one worker to get those first 20 units. My total cost is 15. How would I find my average total? It's just that total cost divided by quantity, right? And then I would go through and do that for every subsequent quantity. At a quantity of 35, total variable cost plus my total fixed cost would be 20. Divide that by the quantity. There's my average total. Now, how do I get my marginal costs? Well, once again, I wanted to kind of really solidify, you don't need to know your total costs. The change in your variable cost will be the same as the change in your total cost. So here, the change in my variable cost going from 0 to 20 was 5, divided by that change in quantity of 20. 5 over 20 is 0.25. And then what's the change in my variable cost? Well, it's still 5. But now, when I hired that second worker, I'm only getting 15 units. So 5 over 15, my marginal cost per unit was 0.33, or it's increasing. So this is an example where I've only got increasing marginal costs, right? But notice initially, because of this large fixed cost, my average total cost is above the marginal cost. So if I'm adding a cost that is below the old, so we'll go to, adding a cost that's below the old average, my new average should be a little bit lower. Now, if I'm going from 20 to 35, what's my new marginal cost? 0.33. That's below my old average. So what's true about my new average? It's going down. So when marginal cost is below the average total, your new average should be lower, or it's decreasing. Same kind of idea. If I go from 35 to 45 units, the new marginal cost is below the old average, so my new average is a little bit lower. Now, if I want to go past that quantity of 45 to 50, well, there at a quantity of 50, my marginal costs are 1. So the additional costs are greater than my old average. What happens to my new average? It's now a little bit higher. So you can see, you can prove this to yourself using actual values, that when your marginal cost is below the average total, your new average will be lower. As soon as those marginal costs are above the average total, your new average is going to be higher. Now here we don't have a point where they're exactly equal to each other, but that would be what? Somewhere in between 45 and 50 would be kind of that point where they intersect. Okay. So these kind of values would line up with this idea, right? So in the short run, we're going to have both an average total cost curve and an average variable cost curve. Okay. So what's going to end up being true, those same principles, that relationship between marginal costs and average total, the same thing applies to the marginal cost and the average variable. So marginal cost will hit both the average total and the average variable at their minimum points. Okay. And there will be a difference between the average total and average variable in the short run because there's going to be some things that are fixed. So we're going to have an average fixed cost. That would be the difference between our average variable and our average total. Okay. Any questions here before we keep moving? I think if there's anything else I want to say here. We'll save this. Let's just, since we're doing this, let's go right to the participation quiz. And it's just really another example of computing some of these things. So I think it'll help. So let's say we've got this table and we have a little more information here, but I want to know what is the total variable cost of the 20th unit. So I'm going to write this down here real quick. In fact, I might make this one just a little bit trickier. So we have average total, average variable, average fixed. Okay. So I had what? 45, 35, marginal cost. We did 25. Now I'm going to leave this one out. I think I gave that to you, but I'll kind of show you we could do some of this stuff. So 23.33. This is just so I don't have to keep bouncing back and forth between the slides and the doc cam here. So let's say I do 28. Let's say I do 2 here, 40, 50. What else did I miss? 27.5, 15, 20. Okay. So I believe the question asks, what's the total variable cost at the 20th unit? Well, this one, if I know an average, right, and I want to find the total, as long as I know the quantity, it should always just be that my average variable cost is equal to my total variable cost over the quantity. So if I'm looking at that, no, I already forgot, the 20th unit, right? The average variable cost is 25. How would I find my, just multiply both sides by 20, and I get that my total variable cost is what? 20 times 25, so 500. Okay. Now, what if I instead had asked you about what the total cost was? Okay. Well, I don't have the average total, but how could I find my average total cost? That would simply be my average variable plus my average fixed. So I know that my average total cost here would be 30. Then it's the same sort of idea. I know my average total cost is the total cost over a quantity. If I know the average is 30 at a quantity of 20, now just a little bit of algebra, I get my total cost there would be 20 times 30 or 600. Okay. So from the averages and the quantities, I can always back out what my totals are. Okay. Any questions on that one before we keep moving? Okay. Now here's where I did something a little bit different. So in the quiz, or the participation quiz, I asked you, what's the total fixed cost at a quantity of 60? Well, you might look at this and say, well, I don't know the average fixed cost, so how the hell am I supposed to be able to find that, right? I can't use this kind of method. But what should be true about my total fixed cost? They're the same if I were to kind of add a column in, it would be the same at every single quantity. So as long as I know the average fixed cost at any quantity, which is just my total fixed costs over that quantity, I can calculate my total fixed cost, and that should be the same for every unit. So here, I'm going to choose this one because I think it's a little bit easy, but like quantity of 20, average fixed cost is 5. My total fixed cost with a little bit of algebra there should just be 100. So if I had a total fixed cost column, it would just be 100 at every single quantity. So the total fixed cost at that quantity of 60 should just be 100. Okay. So we're thinking about this quiz, and we're filling it out. We just found, well, if it'll load for us here. Come on. All right, there we go. So not 2 days in a row. 500 was that total variable cost of the 20th unit, and the total fixed cost would be 100. And this would be the same if I asked you for the 50th, 40th, 30th, 20th unit. Our total fixed cost will always be the same. Okay. Now, if I wanted to find the average fixed costs at the 60th unit, what would I do? Simply average or add up my average total and, sorry, that's not what I would do. If I wanted the average fixed cost, it should be the difference between my average total and my average variable costs here. So if I look at what that difference is, it should be what, 1.666 repeated. I could also say, okay, I know that the total costs, fixed costs are 100. So 100 over 60 should give me that same value. Sure enough, if you do 100 over 60, you get that 1.66 repeated. Okay. So two different ways of, now I didn't ask you that question, but just to kind of add it in there. Okay. All right, now a much more difficult one would be, how do I find the marginal costs of that 40th unit? Well, let's think about how would I calculate marginal costs? Okay, so my marginal costs are the change in my total cost divided by a change in quantity. Okay. We also said, because I don't have as many average total cost curves or cost values here, maybe it'd be easier to use my average variable costs. And we said marginal costs, the change in my total cost, it's all coming from the change in my variable cost, so I can use that variable cost as well. Okay. So if I want the marginal cost of the 40th unit, that's going to mean I'm looking for what were my total variable costs at the 40th minus the total variable cost of the 30th unit, divided by, I was going from 40 to 30 units. So do I have my total variable costs? No, but at 30 and 40, I know my averages. So if my average variable cost is the total variable cost over the quantity, at a quantity of 30, my average variable costs were 23.33 repeated. So if I do a little bit of algebra here, I get that total variable cost of the 30th unit. 30 times 23.33 should be 700. Okay. Any questions on that idea before we keep moving? Okay. And then I would do the exact same thing. I need the total variable costs at the 40th unit. So that would be, sorry, the average variable cost would be the total variable cost of the 40th unit over that quantity of 40. Well, what are my average variable costs at 40 units? 25. A little bit of algebra, 40 times 25. I get that total variable cost of the 40th unit would be, no, not 800, 25, not 20. So this would be 1,000. Right? So now the change in my total variable cost was going from 700 to 1,000. Change in the quantity of 10, 300 over 10 should be a marginal cost value of 30. Okay. Any questions on that idea? So to find my marginal cost, if I only had the averages, it's a little bit more work. I've got to come up with the totals based off of the averages. Now, once I have those totals, I can find what the change in my total costs were. And I don't even have to have my total costs. All I need are my variable costs, and I can do the same thing. Now, let's say I did want to do it using these total cost values. I could actually, well, I've got the average total cost here. right? So I could figure out 40 times 27.5, I think is 1100. What's the total average total cost? Well, I have to find my average fixed. Well, I know that fixed costs are 100, so 100 over 30 would be 3.33 repeated here. So this would be 26.66 repeated times 30 should give me 800. It would be the exact same change in total costs of 300. So it doesn't matter if I use my total or my variable cost to calculate my marginal cost, I should come up with the same value. Okay. Any questions? I know I kind of just talked through that one, but here we go. So how did I find my average? I did 100 over 30, so this was 3.33 repeated. That would make this 20.66 repeated. Now I know the averages, I know the quantities, I can back out the totals. If I do that math, I'll end up finding the exact same thing. Okay. All right. So with that idea in mind, that should cover us for the quiz here. So that answer was what? 30. So hopefully you got everything answered in there correctly. 500, 100, and then 30. Okay. All right. So moving away from these costs a little bit, we're going to start thinking about the difference between the short and the long run. So in the short run, we said some things are fixed. In the long run, and what is the definition of the long run? It's basically just long enough to where we can change every factor of production. So the example that I'll use is, in the long run, I can move to production facilities of larger and larger sizes. Overnight, I can't do that, right? So in the long run, everything is variable. So what ends up being true in the long run? My average total cost is the exact same as my average variable cost. My average fixed cost goes away. In the long run, if everything is variable, my fixed costs will always be 0. Okay? So if my fixed costs are 0, then my average total is the same as my average variable. And that marginal cost curve will still intersect them both, since they're the same thing now, at their minimum point. So this would be kind of our efficient point of production, our efficient scale. Right? It's where the per unit costs, that's another way of kind of, another way of saying average total cost. It's where my per unit costs are at their lowest. Okay. So just to kind of give an example here, and I've got it in the slides. I'm going to draw it out because I think I can do a slightly better job, and then we'll just rehash it in the slides. So let's say I'm producing something, and I'm currently in this like small production facility, right? So the efficient scale is going to be somewhere down here. Right? Now, if I think about, I could move to a medium-sized production facility for any quantity in this range. What size production facility would give me the lowest per unit costs? Well, it would actually be the small, right? So like any quantity below this, I should choose to be in that small production facility. Now, if I start to go to quantities over here, now where are my per unit costs lower? Not in the small production facility, but actually in that medium-sized production facility. And then eventually, you can think about, I could move to a large production facility. So still, at every quantity here, notice the medium-sized average total cost is still below the average total cost of the large and of the small firm. So it's still optimal, or I'm still having the lowest per unit cost between these quantities to be on that medium-sized production facility. However, as soon as I want to produce past this quantity, where are my lowest per unit costs? Well, technically this small one is way up here. So my lowest per unit costs are now in that large production facility. So in the long run, as I produce more and more, I will kind of switch what short run average total cost curve I'm on. A lot of companies, as they're growing, initially, they might be kind of forced to be in this small production facility, but as they want to produce more and more, they eventually can get to this point where it now makes more sense to switch over to a medium-sized production facility. And if I wanted to kind of continue going past that point, I'm going to have to end up in that large production facility. Okay. So same kind of idea here in the slides, right? If I'm thinking about any quantity down here, the lowest per unit costs are in the small facility. Now they're in these quantity ranges at the medium-sized production facility, now past QB. Here, the lowest per unit cost would be to be in that large production facility. So my long run average total cost will just be the lowest of all of those three short run average total cost curves. Right? So wherever the minimum point is on all of those short run average total cost curves, that would make up my long run average total cost curve. So just this red line. Now, a more continuous view of this would be, I don't just face three different production facility sizes. I've got a whole bunch available to me. So I'd really be choosing like the lowest average total cost. And there's all these different size production facilities I could then move to. So the minimum of all those average total costs, those short run average total cost curves, that would make up my long run average total cost curve. Okay. So initially, right, when I've got quantities where I can change this fixed factor of production, and by producing more, I'm lowering my long run average total cost. I'm moving to like more and more efficient production facilities. We say that a company is experiencing economies of scale. By scaling up production, I'm lowering my per unit costs. Okay. Now, I drew this range bigger than it probably is in practice, but there will be at the very least, there would be like two quantity values that moving in between them. If you change this fixed factor of production, where increasing my output actually doesn't change my per unit cost at all, or my average total cost is the same, we would call this constant returns to scale. And then if I ever am producing more output, and as a result, I end up on higher and higher short run average total cost curves, well, there my per unit costs are increasing by increasing production. So we would say that a firm is experiencing diseconomies of scale. Okay. So diseconomies of scale are when my costs are going up, long run average total costs are going up. Economies of scale, when my increasing quantity, my long run average total costs are going down. Constant returns to scale, they're not changing. Okay. Any questions on this before we keep moving here? Okay. Let me think if there's something else I wanted to say about. I think that should cover it. So the next thing we'll do is kind of introduce what I will finish up talking about at the start of class tomorrow. But let's say I have we want to start to, after this exam, we'll really heavily focus on 4 specific types of markets. So perfectly competitive, monopolistically competitive, oligopoly, monopoly. A perfectly competitive market is going to be a market where we've got a lot of firms, right? So each firm is going to have a very small percent of the overall market. Now, a monopoly, you might be familiar with the game or the term, it's when there's only one firm. So if there's only one firm, what percent of the overall sales do they have? 100%. So we're kind of thinking about moving from this perfectly competitive market with many, many, many firms and buyers towards this monopoly. We're getting less and less competitive markets, or the market is becoming more concentrated. All of the sales are concentrated in a smaller number of firms, the most extreme being just one firm. Okay. So we want to have a measure of this market concentration. And, ideally, if we're thinking about for consumers, we probably don't want there just to be one employer. So we kind of want a market that's going to look a little bit closer to perfectly competitive, and we'll talk more about why after this second exam. So the measures that we're going to have for market concentration, the first one we'll talk about is this 4-firm concentration ratio. It's pretty easy. We just take the 4 largest firms, we add up the percent of the overall market share they have. That's your 4-firm concentration ratio. You can imagine if I had just to kind of give you some extreme examples to make the point. Let's say I had 100 firms, each sharing market share equally. Well, then the top 4 firms, each one would have 1%. So in that industry, what would the 4-firm concentration ratio be? 4. Now, if I have a monopoly, one firm has the entire market share. So they're the only firm. Add up the top 4 firms. Well, there's only one. There we end up with a 4-firm concentration ratio of 100. Now, this measure is good to be able to like compare really like, oh, is this a really unconcentrated or a really concentrated market? And if I had a different measure of like 20, I could say this is a more concentrated market than this one is. But it kind of has a flaw in that, well, what if I had 4 firms sharing the market equally? Well, there the 4-firm concentration ratio would be, well, each firm would have 25%. Notice I still end up with the same 4-firm concentration ratio if there's 1 or there's 4 firms. However, this industry is clearly a lot more competitive. We have 4 firms, each one is splitting it evenly. That's more competitive than only having 1 firm selling everything. But we can't differentiate between those types of markets simply looking at that 4-firm concentration ratio. Okay? But we got to walk before we can run. That's going to be our first measure. So closer to 100 means that it's more concentrated with a small number, all the market shares with a small number of firms. Getting closer and closer to 0, or like a concentration of 1%, we're getting closer and closer to these perfectly or monopolistic competitive markets that have a lot of competition. There's not as much market concentration with only a small number of firms. Okay. So we'll kind of run through some examples next class. This will be kind of like the practice problems that we review. Oop. What we're also going to use is this other measure, which is the HHI, Herfindahl-Hirschman Index. So we will start tomorrow's class looking at how we calculate this measure of concentration. It does a better job than this 4-firm concentration ratio. So we'll work through some more examples of calculating this 4-firm concentration ratio. I'm not going to be as heavily focused on that. Wink, wink. It might not show up on the exam. But I do want to spend some time talking about this calculation of the HHI and showing how it is a better measure of market concentration than that 4-firm concentration ratio, and how, go through the steps of how we actually compute it, right? And then I've got some different markets where we can kind of see like, heavily concentrated, not as heavily concentrated, a lot, more spread out. So we'll kind of finish this discussion at the very beginning of class tomorrow, right? After we do that, after we do that, and I will kind of line that discussion up with the practice problems that are in that practice exam. So first 5-10 minutes, we'll talk about the HHI and go through the problems in the practice exam that relate to that. After that, I will take questions from you guys of which ones you want to see me cover, or I'll start picking and choosing. We probably won't have time to work through every single problem, so I would try to take a look at that and think about the types of problems, maybe the more recent stuff that you really want to make sure you see me work through examples of tomorrow. But we will do that at our usual kind of class time. And if there are no other questions, I'll make that Module 9 quiz available. It doesn't have any of the market concentration stuff, so only up through what we talked about with that long run average total cost curve. And then that participation quiz from the day, everything due at the end of the day tomorrow. Okay? So I'm going to stop the recording there. If you have any other